Weekend, let's see. So we've got homework due in 2 days. How are people doing? Can I just look? Everybody can do this anyway, so I guess I won't embarrass anyone by like putting it up. Several people are done. Some people are almost done. All right. Once again, if you get stuck, you need help, talk to me or Nick. Some of these people might be on teams too, so just because there's some folks down in the low part of the picture doesn't mean that they haven't made progress because they might be part of the team. So, but yeah, if you need help, if you have questions, Nick and I are always on Slack pretty much every day. I've got to get the next machine up, and I'll have that up by next time, and I'll assign the next 5 levels, the first 5 levels of that machine, which is called Blade, which is like the same exact IP address as Razor, except for port, I think, 2015 instead. Yeah. So, same deal. And we'll have to forward a port out, and I'll probably be doing that today, so I'll show you how to do it. What else? Does anybody here have an IP camera? You know what I mean? So, okay, so there's all these IoT devices. What's IoT? Internet of Things, right? So you can have your thermostat, you can have your doorbell on the internet, you can put your microwave, home security system, DVR. All these things can be on the internet, and this is nice in some ways. For example, if your thermostat's on the internet, as you're going home and it's really cold, you can warm your house up in advance if that's important to you. You can check your home security system while you're at work. In the case of an IP camera, so my girlfriend has a 2-year-old, and in order to keep an eye on the 2-year-old who's in a separate room, I mounted an IP camera over her crib. And it's pretty cool. Like when I had my kids, we just had audio monitors, baby monitors, you know, so that you could hear them, but there was no video. Now it's video, and the easiest thing to do is to put the video camera on your Wi-Fi. And then from the bedroom, you can check on the little girl and see if she's awake or whatever. But you can also access it from anywhere. Right? I could pull her up right now on my phone and see what she's up to if she's in her crib. That's cool and terrifying, right? Because I don't know what the security is on this thing. It was $35 off of Amazon. It's going to be made by some OEM out of China that there have been a notorious number of security failures in these Wi-Fi modules that are bought by another Chinese company that have default login credentials like Telnet credentials, where you can just log in from anywhere. And these things get recruited into these massive bot armies and turned into, you know, DDoS attack zombies. And also because somebody else be like watching this little girl from anywhere in the world. It's weird. I'm not sure why it would be interesting, but I wouldn't want that.
Did you read the article a couple of years ago about the hacked Wi-Fi camera where it also allows you to communicate through it? So there was something about the malicious user actually got into it and started screaming at the baby through the camera.
Because that's useful. So this thing lets me talk to her too. Like this little microphone, you can press it on the app and talk to her. So yeah, someone could, that's cool.
I feel like that's for the dogs, right? I feel like a lot of people have these for...
They want to talk to their dogs.
Yeah.
I can't relate, but I think you're right.
People I used to work with just all day.
All day at work, they're talking to their dogs?
Yeah, like some people just leave it up, you know, while they work. Like they just you know, interact like with their dog, yeah.
Interaction. Or very like codependent partners maybe. Set them up at work and just be like talking to each other all day long. Okay, but anyway, yeah, so I'm like very conflicted. Maybe I should take this thing down or something. It doesn't need to be on the internet, it just could be on the Wi-Fi. I thought maybe some of you would know. That sounds like there have already been security breaches. I know that IP cameras are notoriously insecure, as are most IoT devices.
Yeah, I mean, as a blue teamer, my kind of questions are like, well, maybe put it on a different Wi-Fi instead of keep it on the normal everyday Wi-Fi, or you know, some other trick or then still allow it, but then protect yourself from it.
So, I mean, taking a separate Wi-Fi, that would be trying to forestall cross-contamination from someone who breaks into the IP camera and then can get onto your normal network.
Exactly.
But I just don't even want anyone to see this little girl or talk to her, God forbid. Right? And the way these things usually work is through UPnP. So we're not going to do this at all, but you know, because of port forwarding, which we've talked about, and this IP camera is not going to have a public IP address, right? I mean, it's going to have a private IP handed out by the DHCP of the Wi-Fi router, and then it's going to have to somehow make itself accessible through the internet, through some port forwarding. Well, there's this thing called UPnP, which stands for Universal Plug and Play, and like SSDP, which is this discovery protocol that allows these things to find each other. The router can find the camera, other devices can find the camera. It automatically can request from the router, please forward this port for me through UPnP, and the router, if it's turned on, will allow the port forward so that the IP camera can be visible from the outside. And all of this stuff has all kinds of weird flaws in it. People show up at Black Hat and DEF CON all the time and talk about these things. Right? So I don't know if there's a good way to secure it, but I'm gonna go figure it out.
Would it be better to just like use a camera connected to like a Raspberry Pi or?
Yeah, that's what I was thinking.
That would be better. I mean, a better would be just a completely separate system that's not even on your Wi-Fi, right? I mean, you can just have, well, I mean, the old school way is just to have an audio monitor. Even that's susceptible to sniffing because it's going over RF, and so someone with a sniffer outside can pick up on that. At least that's a read-only attack. It's a passive attack, right? They can't actually inject their voice into the audio monitor instead of a megaphone. I don't know. God, it's a scary place time to be alive. Anyway, I'm sure people have already looked into this extensively.
There's a lot of stuff with Raspberry Pi. I think Raspberry
We're
Pi.
attacking them?
No, like a lot of software for Raspberry Pi is like monitoring software where it only runs on your local network. So you have to connect to your local network first and then to the Raspberry Pi. Like,
That would be better than UPnP.
yeah.
All these IoT things work on UPnP because they're all forwarding themselves out to some central IP address that you can connect to and talk to them. So it's,
Of course, you know in the future they're going to require actual internet access. So even if you block it now, eventually that refrigerator of 2030 will be like, sorry, I'm not getting to the internet, I don't work.
yeah, right, yeah.
No fridge.
It's like not having power or something. No, I mean, we're not far off from, 30,000 refrigerators attacked Bank of America today. Okay.
Yeah. I can't wait for my washing machine to turn into an attack vector.
All right, so today we are shifting gears. Probably no more GDB or buffer overflows or format strings or any of that. We talk about the web. It's a completely different ecosystem, right, than this binary stuff. And our model, more or less now, is going to be you're a remote attacker with a browser. You're not on the machine, although on Blade you have an account. But in general, the attack model will often be thinking of as you're the browser, and there's a server with juicy stuff that you'd like to get your hands on. How are you going to get it? Okay, so a lot of this should be review. I just asked my 16-year-old students in that homeschool thing I'm doing if they know how to write a web page, and they both said yes. And I said, where did you learn it? And it's kind of like, you just learn it. Like, it's not taught in high school. I don't know if it's taught in college. Does anybody go, okay, here's how we build HTML pages? No one tells you this, right? Your computer science students, it's assumed you can just pick that up by osmosis or something through your life, right? It's not even a coding language. It's just a markup language. And probably everybody here has built many web pages and edited HTML. These days, a lot of it's WYSIWYG, right? So it's you use an editor that just lets you type directly in the format of the web page itself, not in the underlying HTML. But you're all hackers, so you've looked at the HTML and written HTML, and I'm not going to teach you HTML or CSS. What's that?
Cascading style sheets.
Cascading style sheets, which is different from XSS, which is cross-site scripting, okay, which is an attack that we will talk about. So the model is client server. And the client is the browser or some substitute for the browser like wget or curl, what are those?
Command line browsers.
Yeah, well, they're command line utilities that speak HTTP that will go and fetch web resources. Phantom.js, anybody ever use Phantom.js? It's a big deal now. It is a headless browser. What do I mean headless?
No UI.
No GUI, right?
Yeah.
It's just machine code, or there's no rendering of the content, but it can run JavaScript. So the first two can't run JavaScript. So if you say wget a page, it'll go out and speak HTTP and fetch that page and save it to a file for you. But if that page has JavaScript, it's not going to run the JavaScript. It's just going to give you the JavaScript in a file so you can look at it. Phantom.js will, if you want it to, execute the JavaScript. And of course, if the JavaScript tries to interact with the DOM, what's the DOM?
Document object model.
Document object model, which is the object that is your window and your web browser and all the other objects that are part of the experience. If it does that, it just simulates, it doesn't render it for you because you don't have a GUI. Why would you ever want something like, let's say, Phantom.js?
Is this what you'd write like sneaker bots in?
Yeah, I mean, you definitely might want this for bots, right? I mean, bots do things like index web pages, right? That's what sometimes called a spider. That's what Google does all the time, is it's crawling the web and taking pages and indexing them for search purposes. Why would you ever want to execute the JavaScript on a page as you're crawling, or if you're a bot?
Because now most web pages are JavaScript anyway, so your HTML is almost non-existent.
So the HTML itself is actually generated from JavaScript. It's not statically present. Okay, so if you want to see what's on the page, you have to execute JavaScript. Almost certainly the Google crawler and other Bing search engine crawlers are doing this. Other reasons why you'd want to execute JavaScript headlessly?
Maybe you want to log in into some web page.
Okay, so you want to automate the process of maybe logging in. Very commonly, it's for testing purposes. So companies that have massive websites, like Amazon or something, they want to have an automated test engine, making sure that nobody's breaking basic functionality, so they'll constantly be crawling their own web page to make sure that things aren't broken, or to test. You can also test different user agents this way, to make sure that you make a change, you can test all 27 user agents that you support. In this class, I run Phantom.js for level 7, I think, of Blade, which is cross-site scripting. So with cross-site scripting, somebody tell me what's cross-site scripting. We'll get to it in depth, but. Do you know?
It's executing arbitrary JavaScript, or executing arbitrary code, something that uses something that can do that statement.
Okay, so that's the web server over there, and I'm the bad guy and you're the good guy. I'm getting my JavaScript to run on your browser as if it came from the server, not from me, right? So I get to inject JavaScript against you, and your browser thinks it came from the server, so it trusts it with whatever information is relevant to that server, including the cookies that are available, session tokens, passwords, things like that. And I do it by bouncing my JavaScript off the server so that your browser thinks it's coming from the server. A simple one is if there's like a comment forum, you ever participate in, you like boating or motorcycles or photography or something, and you go to a forum that's PHPBB or some forum where people log in and post questions and people post answers. I might post some JavaScript. And then when you come along to read what the latest news is on the forum, you receive JavaScript from that forum, and your browser thinks it's coming from the server, but it's actually me. I'm the one who put it there. Right? This is why every single package every single forum package out there for commenting strips JavaScript, so that you can't do that. On level, I think it's level 7, the admin is coming in, logging in periodically to some comment forum, and you have to plant JavaScript so that when he logs in, then you steal his credentials. Because he runs JavaScript that takes cookies and then emails them to you or writes them to a file or sends them to you back to you somehow. And in order to do that, I'm the admin. I got to keep logging in and being a victim for you. Here's my stuff. Here, take it away. Steal my stuff all the time, and that gets tiring. So I just use Phantom.js, which has to execute JavaScript because you're planting malicious JavaScript in the first place. All right, we'll talk more about XSS later and all the different variants of it and so forth. Okay, so the server, of course, is the web server. The number one most common web server in the world is called Apache. You've heard of it? Say yes. 1.3 is still around. It's considered the old version. And these days we're in the 2.x. 2.4 is the latest. Apache 2.4. There's also IIS, which is it's the Microsoft web server. And I used to think like no one must use this is like Windows Phone, like nobody actually uses it. But IIS actually is fairly commonly used by Microsoft shops. So companies that have websites, which is pretty much every company in the world of any size, has a website. Some of them have extensive capabilities on their website. When they set up shop, they decide to be either a LAMP stack, which we'll talk about a little bit, but they're basically Linux-based or Windows-based. And once you decide on the operating system, you pretty much have decided to take on a subset of the ecosystem. And so if you're going to run Microsoft Windows Server, you're going to run IIS as your web server. You're going to run what kind of backend stack? C#. .NET. You heard .NET? That's a massive framework that includes Visual Basic and C# and ASP, Active Server Pages, and their database engine, and all of the Microsoft stuff kind of comes together. And there are people who are just experts at this stuff. If you go with LAMP, which stands for Linux, Apache, MySQL, PHP, then you're going to have a bunch of PHP programmers, which, how many people know PHP or at least have used it ever? Maybe 20, 30% of you. That's considered sort of the hobbyist language, although now a lot of serious businesses use it too. And then in the Fortune 500, they use what language?
Largely Java. Right?
Mostly Java, almost always Java. Java on the back end. And then they use like JSP, Java Server Pages, and Java Servlets in a servlet engine. So these are these different kinds of like pieces of software that kind of glue together, and certain companies just buy into them, and then they're stuck forever basically with those backends.
Well, and the new one is a full JavaScript stack as well. So you have Node.js in the back end,
Node.js in the
and
back.
like Angular, or I forget what the other one is in the front end.
Ruby on Rails is big too these days. On the back. Okay, so and then Java usually runs on Tomcat on the back, which is a servlet container. Nginx is a newer, lighter, probably faster engine web server than Apache, and a lot of the market share has gone over to Nginx. I say market share because Apache's free and so is Nginx. IIS costs money. What's GWS?
Google?
Google's web server. It's a major part. A huge proportion of all web queries go to GWS, but it's a proprietary web server written by Google, owned by Google, and not open sourced. But it's important because it's Google. And Google has a massive, because of Gmail and web search and other services, has a massive proportion. All right, so The way that the web works is it's request reply. The client makes a request and then waits for a response from the server. And both use the HTTP protocol. What does it stand for? I usually don't ask you this, but
Hypertext transfer protocol.
Hypertext transfer protocol. Hypertext being HTML and CSS and all the images and all the JavaScript. It runs on TCP/IP. It doesn't run over UDP. And defaults to port 80, as you know, right? Okay. So HTTP, which we're going to care about quite a bit in this segment of the class, comes in various versions. The original version is called 1.0. I think it only lasted a year before it was supplanted by 1.1. And this is around 1990, 1991. 1.1 is still the predominant flavor of HTTP, although HTTP 2 has come out recently. And something like, right here, 31% of the top 10 million sites support HTTP 2. So we don't have full adoption yet. I'll talk about HTTP 2 in the next slide. HTTP is connectionless, even though TCP/IP is a stateful protocol. It doesn't maintain long-term connection. It doesn't have sequence numbers to maintain a relationship. It's very much, the idea of HTTP is, can I have this stuff, like index.html, please? The server sends it to you and says, I don't know who you are, goodbye. Right? Now, in truth, we don't just hang up the connection. Why if you're a browser and you go to a server and you say, may I please have index.html? And the server says, here it is, and then hangs up the connection. Why is that bad?
Because you need more resources from that page.
Almost certainly, right? Gone are the days when index.html is the end of the story. Almost certainly there's JavaScript, there's images, JPEGs, there's maybe even animated materials and resources. There's CSS. It's commonly not within the HTML. It's a separate CSS file. So there are other resources that are going to be fetched almost every single time. And so in 1.0, there was this keep alive option that said, give me this many more seconds before you hang up on me, because I have more requests to make. And why is that better?
Avoids three-way handshake like multiple times.
You have to do another three-way handshake every single time you want to go back to the same web server to get the next resource, and that's costly. Okay. In Apache 2.0, it would be 15 seconds before it would hang up on you. In 2.4, it's 5 seconds. Last time I used Google on GWS, it was like a minute. I don't know if we did that. Maybe we'll do it today. All right, HTTP 2, which is coming more and more every year. There's more adoption, so you're going to start seeing it if you're going to spend your professional life dealing with web stuff. Some of you may. You're going to see more and more of this. There is no 2 point, by the way. It's just /2 deliberately. It's binary. So today I'm going to be typing text into Netcat and talking to web servers. And you can do that with HTTP 1.1. But with HTTP 2 you can't, because it's binary. It multiplexes the connection. What do I mean?
Set up different channels.
Say again?
Set up different channels, as in you can open multiple TCP.
Okay, so over a single TCP connection, I can be getting a piece of the HTML and a piece of the CSS and some of that GIF at the same time. I can interleave chunks of different files. I don't have to wait till one fully resource is complete and then start downloading the next one. So this improves efficiency. Header compression, compression's faster than not compression, right? Server push, so the server can initiate sending you resources it knows you're going to be before you even request them. That means the browser doesn't have to parse the HTML to figure out what resources it needs to request next. The server's already sending them to you. By the time you're requesting them, they're already on the way. there was during the development of the standard, there was a push for mandatory encryption every time. That didn't go through. But most HTTP2 is encrypted, just because if you're advanced enough to run HTTP2, then you're probably doing TLS. Cookies still exist. There was a push to get rid of cookies, but they're still there. We won't ever see this. So on Blade, everything's HTTP 1.1. So your browser's only going to be requesting HTTP 1.1 from it.
For that like binary as opposed to text, does that mean there's some compiler-esque thing that
How does it?
stuff into binary?
So there's a header, which we're about to do. That header is not part of your web page. So you don't take HTML and compile it into HTTP2. This is just the protocol that transfers HTML over the internet. And there's a header that goes before the HTML is even sent. And it's got things like what's your cookie, what's your caching, what compression do you use, things like this. That header is generated by the web server. And it's normally generated as text, as we're about to see. But now it's going to be generated as binary. And the browser is going to parse it as binary. So there's no compiler. It's generated at runtime as needed. Other questions? Okay, so we'll stick to 1.1 for this course, which makes things easier because it's actually human readable. It's text. The structure of HTTP 1.1 is first line has like the action. If it's a browser, it's the request. If it's the server, it's the response, but has high level action that's occurring. Then all your header lines occur after, 0 more headers. These are also in text. And then there's a host header if it's a request for HTTP 1.1 that we'll see in a minute. And then there's a blank line. Blank line indicates end of headers. And then if there's a body, that appears next. Okay? So the action, 0 more headers, blank line, and then a body. It's the structure, and it's the structure in both directions. Yeah?
And then these are wrapped up in the TCP header, IP header, and so does this, so all the, if I was to Wireshark this, all the TCP IP headers, it's going to look binary or whatever, but then it's going to have plain text as soon as I get to the HTTP header.
Right. So if you looked at this in Wireshark, the HTTP is going to be encapsulated in TCP,
Yeah.
and that's going to be encapsulated in IP.
Yeah.
And you're right, the IP and TCP headers will be binary, but then the payload down here is going to be all in ASCII.
Okay.
Yeah. And Wireshark will parse all this for you.
Yeah.
All right. So in the client-server model, the client makes the request, right? Servers don't reach out to your browser and say, hey, would you like to buy a book? It's you who decide whom to speak to and what to request. The two main request types from your browser over HTTP are GET and POST. There are a bunch of other options. One's called Options. Options is useful for switching to HTTP2, by the way. And you can intermix HTTP2 and 1.1. These are not as commonly used. So you say, we'll do a demo in a second, but you say GET or POST, space, then the URI, which is the resource indicator. You can do this either with an absolute path or relative path. So here's an example of an absolute path that tells the server where to go to get the resource, index.html, or a relative path, which is going to be relative to whatever the document root is. And then the protocol name. So I'm doing HTTP 1.0 here, but most commonly it's going to be HTTP 1.1. And then the line terminator is \r\n. What are those characters?
Line feed, caret feed.
Yeah, it's character return and then line feed. So do you know this horrible situation the world is in where, yeah, this is the Windows end of line. So the original intent is on a typewriter, the carriage return just returns the cursor all the way back to column 0, and then the line feed shifts the paper up 1, right? Or on your screen, puts the cursor down 1. And so on Windows, it's saying to end the line, return the cursor and go down 1. And that requires 2 characters. But on the Unix world, it's just line feed, right? Just a ASCII 10. And this distinction between, have you ever had problems because of the difference? Just like something's in DOS format or Windows format versus Unix format can cause a headache. By default, Netcat uses the Linux format, and if you use capital C, it'll add the carriage return too, which can sometimes solve problems that you have if you're dealing with Windows type machines or HTTP, because HTTP expects both, yeah.
I also have issues with tabs. And when I write a bash script in Windows and transfer it to Linux, I don't always have to change the tabs. What's with that?
Yeah, tabs can be, a tab is just a single ASCII character. It's like an 8 in ASCII. And it means go to the next tab stop, but who knows where that is? It depends on what editor you're using, what operating system you're using. And so converting tabs to spaces is the most, it wastes some space, because one tab might turn into up to 7 spaces or something. But there are utilities on Linux that do this. I can't remember the name of them. But yeah.
Things like DOS TMX or something like that.
Yeah.
What's the difference between URI and URL?
That's a good question. The smartass answer is URI is indicator and L is location, but there is some distinction. I never can get excited about well, if you have a protocol name, then it becomes, I don't know what it is. Sorry. When the server, there are all these standards bodies, right? And they get really anal about this is called this, and you should never, packet only means that, and I can't get excited about all the formality and precision in the language. Okay. When the server responds, it responds with a first line that is the status of the request. So its answer comes back in 5 different families, and you've probably seen some of these numbers before. So a 1 something something, 3-digit number starting with a 1 is informational. 2 something something is some kind of success. You've probably seen 200 maybe before, which is usually 200 OK. It's the status coming back. 300 families for redirects, so we're going to 302s and 303s and 304s. We'll see some of those in a little bit. And these are the ones you've probably seen the most of. 400 family is an error on the client side. So 404 means not found, right? There's t-shirts with memes and stuff. 404. 403 is forbidden, that's a permission problem. And then the 500 family is some kind of internal error on the server side. And usually it doesn't tell you much about that error because security, right? If something's wrong on the server side, they're not going to be like, 500, your password attempt was really close, but the 4th character is slightly off, and they're not going to give you that. All right. We just went through these. SSL used to be a rare thing. I said this before, but SSL is no longer the name. It's called TLS because of a lawsuit, but everybody still calls it SSL pretty much, even though they're not supposed to. Same thing as TLS. HTTPS is just HTTP but over SSL. So it's encrypted and authenticated. That means that if you were to sniff the wire on a browser talking to a server over HTTPS, would you see the IP address of whom the browser is talking to?
Yes.
Yes, because that's in the IP header. Would you know the relative size of the request and the response?
Yeah.
Yeah, because encryption usually bloats the plain text by a tiny bit, but not triple or something, right? So you know kind of the size. Would you know the timing of the request and the response?
Yeah.
Yes. Would you know the contents of the payload? No, that's going to be encrypted, right? Now, in some world, knowing the timing and the size and the IP address is enough for you to know what's going on. You can actually recognize a Facebook login just based on the size and the timing of the request and the fact that the IP address is Facebook. And the NSA, believe me, knows how to profile encrypted information and so forth. But at least the data themselves are not in plain view. And that's worthwhile. Passwords are protected, for example.
I read that there are TurboTax because it's sort of like a choose your own adventure. You pick like, oh, I'm in this income range, so it sends back certain payloads for that you can see just based on size, and you know the sort of the tree-like structure. You start at one point and it just spams out from that. You can infer information like how much money that person made and like how much they're donating this year and stuff like that.
Yeah, I'm not surprised at all. I mean, I'm surprised that TurboTax is a web-based interactive experience. Usually it's a standalone program that just uploads your taxes at the very end to file them. But there's some version...
Mostly web now.
Yeah. I mean, I use TurboTax, and I just purchase the entire package and bring it up, and I can do it offline.
That's old school.
Yeah. I'm happy with that. I mean, Max is absolutely right. There's like, if you know the whole profile of the experience and what the tree of interaction looks like, you can totally identify. Even though it's got to be encrypted, there's no way they're sending your stuff in plain view.
Right.
But just knowing, the timing and the size and what the tree looks like. Is that a paper, a research paper, or a talk? Or something?
Yeah. I can send that over the Slack.
Okay. Yeah. I mean, phone calls are encrypted too. And the NSA can surveil the phone system, but they're only viewing encrypted information that's going over the internet. Most phone calls go over the internet. We're going away from POTS, plain old telephone system, and more over VoIP. But it turns out if you're looking for terrorists, you really only want the metadata. You want to know who's calling whom, at what time, for how long, and how often are they making those calls to try to make a profile of where terrorist cells exist. And the contents of it, which may even be in a different language that you don't understand, and you don't want to hire a language specialist to try to listen in on the details. Turns out those details don't matter that much. Metadata is actually what you're after. And so, as far as metadata, who's talking to whom, how often, for how long, HTTPS isn't helping because it doesn't hide any of that, right? If you want to browse the web anonymously, you have to use something more along the lines of Tor, right? Wrapped in a VPN. Yeah, and don't run any operating system that's commercial or, right? You have to write your own OS and build your own hardware out of, your own private molecules in your basement or something. You can't trust anybody, which means don't use computers. Okay. But HTTPS is better for security, and the world is now shifting. When I was a kid, Google searches were not HTTPS. They were in plain view. Facebook was not encrypted. They had an option, you could turn it on, but it was not on by default. And there were simple, like Firefox had a plugin called Firesheep that was an automated plugin where you could just go to Starbucks and log into people's Facebook. Anybody who was on Facebook, you could grab their session. Because the session tokens, which we're going to talk about, were being broadcast in plain view. There's no HTTPS, so you could just grab their session token and then assume their login session. Post to their page. Add yourself as their friend, which you clearly are not. And so forth. All right, we'll talk about session hijacking a little bit later. So the way that SSL usually gets insinuated into the connection is that the user will first go typically to a non-SSL site on port 80. So port 80 by default is plain HTTP. Could you serve SSL, HTTPS on port 80? You could. The entire planet would be confused at what you're doing because they would be not expecting that, right? But you could do it, and if all your clients, all the browsers are your friends and they know to put an S on the end, it would work. But it wouldn't work by default. So the typical dance is you type in google.com. Does anybody here type in https://www? Nobody types in https by hand, right? You type in google.com. The browser will default to go to port 80 and then get redirected to HTTPS, and that, your browser will see the S and then go to port 443 at the same URL, and it will know, because of the S, to do an SSL handshake. And then do the whole dance with, like, what's your cipher suite? Let's share symmetric keys. Let's switch from public key over to symmetric encryption so we can go fast. And I think I said this all at the beginning of the class, and someone pointed out that in the case of Google, actually, it's pinned, and they're never even going to bother. The browser knows that for Google, we only go to 443. We don't talk plain HTTP. But for other sites that aren't pinned.
There's a plugin by the EFF called HTTPS Anywhere that will actually do that transformation in the browser for you.
Is it anywhere or everywhere?
I don't remember. I thought it was everywhere, but
I think you said anywhere, that's what I was asking.
Oh.
I think it's called everywhere, but you're right.
I'm still jet lagged.
Okay, yeah. HTTPS everywhere, yeah. Yeah, so it'll do that for you, force the HTTPS. There is an attack, I think we're going to talk about it, called SSL Strip. It's super clever, that is a man-in-the-middle attack against SSL that doesn't work in the face of HTTPS everywhere. But we'll get there. I think we'll get there. All right. So typically what happens, your browser goes to 80, and it gets redirected to 443 with HTTPS, and then you do the dance with the whole SSL handshake, and then you go encrypted and authenticate. And then when the get or the post or whatever comes across, that's encrypted now. So once again, if I sniff an SSL connection, can I see the IP addresses involved? The source and destination? Yes. Can I see the ports? Yes. Can I see the packet length? Yes. Can I see the get, GET? No, that's the payload. That's encrypted. Okay? So I can't see the letters GET. I can't see the resource being requested, which web page within the site. That's all encrypted. And I certainly can't see the headers and the body of all the HTTP contents. Those are encrypted. All right. This actually breaks virtual hosting. Explain why. Yeah. All right. So, what's virtual hosting?
Like caching? Like CDN?
No.
You have a
CDN's a new virtual hosting, yeah?
You have a lot of servers running on a single IP address, probably.
Right. It's actually not a lot of servers. It's usually just one server, but a lot of websites running on one server, which is on one IP address. So, in the old days, everybody had their own IP. And you run a web server and it would have one website on it. But then, we started running out of IP addresses. And for other reasons, we wanted to run multiple websites under one server, especially for like GoDaddy or these big virtual hosting sites. You've heard of GoDaddy? Usually when you want your own website, you don't want like your own machine, you don't want your own data center, you don't want your own IP address. That all is expensive. You'll just go to some virtual hosting company that will say, hey, for $5 a month, I'll host your website. Well, they're not giving you your own machine. They're not even giving you your own virtual machine. And they're certainly not giving you your own IP address because they don't have enough to spare, especially for $5 a month. So what will happen is you'll get an IP address like 1.2.3.4, and there'll be one server that's listening, web server, that's listening on that IP address on port 80. But this web server will have a whole bunch of different websites. It'll have alex.com and john.com and Bryce and whatever, right? And this one IP address and this one web server, anytime someone asks for any of these resources, will serve back the appropriate pages from these individual domains, but they're all on the same machine, all on the same IP address, all being served by the same web server. This is called virtual hosting because they're not actual separate hosts, they're virtual hosts. Okay, so here's a question. Let's say some browser over here wants to go to alex.com. So the user types in alex.com into the URL bar. What's the first thing that this browser does? DNS. All right, so there's going to be a DNS request to figure out where alex.com lives. What's its IP address? And that may be also to GoDaddy if there's a need for an authoritative record. Or it may be cached on 8888. Google may already know the answer to this question. Or it may even be cached locally on this browser. The browser may already know it. But one way or another, this is going to resolve to 1.2.3.4. Okay, so that's happened. Now the browser has in hand the IP address. What's the next thing?
Go to port 80.
Go to port 80 at this IP, right? So make a TCP connection to port 80, send synac ACK 1.2.3.4 at port 80. Okay, that's established. The next thing the browser is going to do is send a get of, I don't know, the default index.html. This is configurable. I mean, actually, it's just going to do a get slash. It's going to say, give me the root document. http/1.1. And this will be relative to the document root for whatever the appropriate site is. What's the problem for the web server at this point?
Doesn't know who doesn't have to
Yeah. I don't have alex.com that you typed in. That was never revealed to me because there was a DNS that converted it to an IP address that got you over here to 1234, but I don't know which of these sites you want. So the answer is the host header. The host header is the only required header in HTTP 1.1. And it was added in 1.1. In 1.0 it doesn't exist, which is one of the big reasons we immediately jettisoned 1.0 to go to 1.1 to add the host header, which is actually mandatory. So host, we'll say alex.com. Now it may also say my user agent is, Safari and my compression type, my key tags, my cookies, all the other things that I want to send back. That I want to send you as well. But this one's mandatory, the rest are optional. And then a blank line, and that ends the headers. Now, when the server sees the blank line, it's going to go down here and say, alex.com, that document root is over here within my file system, and by default, the server is configured to send back the index.html page, and that gets sent back, and then the page is rendered. What if instead of alex.com I had just typed in 1.2.3.4? Can you do that? Can you type in an IP address into the URL bar? You can. What would happen?
You get the default.
Yeah. But it wouldn't know which website to hand you, right? So it'd probably give you some default GoDaddy page or something like that. But it couldn't just know what you were thinking. Okay, so you got this. HTTP 1.1, you need this header for this reason, because they're multiple websites. Now, if you type in an IP address for, let's say, Google, it doesn't need to know which site you mean, because Google's going to have, of course, only Google on its web server. It's not sharing it with a bunch of other things. So in that case, you're fine. But in this case of shared hosts, virtual hosts, you need the header. All right, so now let's talk about SSL. Same thing. This is now an SSL web server. In other words, it supports SSL. These sites are all HTTPS sites. And so we're going to do the same thing again. We're going to type in, this time, alex.com. It's going to do a DNS. It's going to go attempt to get this. And the response is going to be, go to HTTPS now. So you'll be redirected to HTTPS alex.com. So now what happens is you do a DNS lookup, which you already have cached, and you see the browser sees the S and says, I know that when I see an S, I don't go to 80, I go to 443. I do a TCP/IP connection to port 443. Done. And I don't send to GET. Why not?
It's encrypted.
It will be, but right now I'm not going to encrypt it because the server couldn't decrypt it. What's the next step after the TCP/IP connection to 443?
Handshake.
SSL handshake, right? Which is an SSL hello that says, here are the ciphers I can speak, and here's my pre-master secret, like getting ready to share a random number. The server sends back its certificate. You know, here's my certificate blessed by some third-party CA. It's got my public key in it. Okay, let's use this symmetric key. It does that whole back and forth. So let's say that happens. And then you encrypt this and send it over. And then the server decrypts it and says, the host header says alex.com. Here's the web page. Encrypted this time. There's a problem here. The problem is, when I said SSL hello, it needs to send me back a certificate for alex.com, but not these other two. It needs to know, already needs to know which website are you connecting to, because these have different certificates. Right? So when I do an SSL hello, it doesn't know which certificate to send back. Unless we're sharing the same certificate, that actually used to be done and it's a mess. It means that we all are in bed together and we don't want to be, because these are different companies, you know, they want separate certificates. So, you see what the problem is? I haven't gotten this yet. This is coming after the encryption is set up. But I need it now to set up the encryption so I know which certificate to use for this negotiation. Okay. So that's why SSL breaks virtual hosting. And we just went through this. So the solution to this is SNI. SNI is an extension to SSL on this bullet that transmits the host name during the SSL handshake. So what happens is, during the SSL handshake, I go SSL hello, and by the way, I'm looking for alex.com. The server then knows to feed me this certificate. And then I complete the handshake, and then I do the host a second time in HTTP. Okay, questions? Yeah.
It's about virtual hosting. So if one of these sites is, it has a vulnerability, and you attack it and somehow get access to the entire site, it means all of them are now in your control.
That's right.
So
yeah.
How does GoDaddy or these big virtual hosting companies ensure that the website that you're hosting with them is not actually just a front to you want to get your website hosted next to someone else's so you can attack theirs. You have access to yours as well as theirs.
Yeah. So I mean, when you're when you get access to a website, you're supposed to be in a what's called a chroot jail. So a chroot jail is a subtree of the overall file system that you're locked into and you can only see. So you can't just go to a bash prompt and then CD over to Bryce's area and start messing with his files or seeing his files. You're supposed to be limited Now, of course, if there's a vulnerability, you might be able to break out of this jail, but you're not supposed to be able to. And the web server is supposed to segregate, these files separate from those files. And if there's a vulnerability in your site, it should only allow access to your files, unless there's a problem with Apache or a problem with the configuration or the setup, in which case that's GoDaddy's fault. Okay, so let's go look at this. What does a browser typically send? How would we do this? Well, I want to see what a browser is going to send to a server. I want to see what my browser is going to send to a server.
Chrome inspect. Chrome inspect.
I could do Chrome inspect. I'm just gonna use netcat. So what should I do? I want to see what the browser sends to a server. So what do I need to simulate with netcat?
TCP connection.
Browser or the client? I mean the client or the server?
You're being the client at this stage, so.
I want to see what Chrome sends, so I'm going to use Chrome.
Then you'd be the server.
All right. So I don't know, 8080. So that should be open now, and I'm doing it on my Mac. So I'm not putting the P because it's not the Linux version; it's the FreeBSD version. Remember, netcat has 27 versions, and you have to know what flags. And so I'm going to type localhost 8080. No. Oh.
It's already lost.
Yeah, let me change it to a different. I'll explain what happened in a second. Uh-oh. What's going on? This is one of these things where I'm not logged into the right place or something. Is this actually... There we go. All right. So this is a server listening on 8081, and this is what Chrome sent to a server it's never met before. Doesn't know what to send. So it sends get/HTTP 1.1. So by default we're at 1.1, and if you don't specify which resource you want, it asks for the root. This is not the root of the file system. This is not / on the disk. This is / on the document root. So every web server has a document root that you configure, and you say, the web server's file system starts at this subdirectory, and everything is built below that. And a browser should not be able to say, HTTP, that web server, .. and climb up out of the document root and go over. That's supposed to be proscribed, right? That's the .. attack. I don't know what all of these are, but we know what this one is, right? That's the mandatory one, almost always comes first. That's the thing the user typed in, so you can identify which virtual host. We talked about keep alive. User agent is what?
What browser you're coming from.
You're identifying what browser you're coming from. This is so that the server can provide you with a different formatted web page for an individualized experience that runs best on your browser, the right format size and so forth. This is the kind of character sets that are acceptable by the browser. So I'm happy to speak HTML. I can do images. Anything else interesting here? Cookie. Wow, I'm surprised it's sending a cookie. What's a cookie?
A locally stored file.
Okay. A cookie is usually, so who sets cookies? Servers or browsers? Servers set the cookie, right? So if you're a web server, you can tell the browser, hey dude, here's this piece of information. Every time you talk to me, I want you to present this back to me. And browsers, if cookies are enabled, will do this. What's the maximum size? 4096. So if I'm a server, I can ask you to hold on to up to 4096 bytes for me. And if you're willing, you give it back to me every time you talk to me. But you don't give my cookie to any other server. That would be bad. And cookies sometimes have sensitive information. If I'm a server, can I trust you to give me back exactly the same unchanged cookie every time? Like if I go, okay, I'm a shopping site and I see that you qualify for a 10% discount, so I'll just tell you in a cookie, you get 10%. Can I trust you not to change that to 15%? It used to work on Amazon a long time ago now, but you used to be able to change that to a higher percentage and it would just give you more and more discount. Sad face doesn't work, but anyway. All right. Sometimes this information is private. In other words, if someone could steal your cookie, they could usurp your session, could take over, hijack your session, and we'll see examples of that. And this is a session token. So, in fact, if this were a live session that I cared about and you saw it, you could now hijack my session. If you could see this web, if this Netcat were a real web server that you could see.
What does it mean for it to have sent this?
What's that?
To a site that it's
Say
never.
again?
What does it mean for it to have sent this to a site it's like never seen before theoretically?
Oh, so in the past, I've gone to localhost from this same Chrome browser.
Oh.
So it's got cookies live forever unless they have a set expiration date. So you can set an expiration date on a cookie and it'll go away at a certain time. But this one doesn't have an expiration date because it would be written right afterward. It would say expires at this date. So since it hasn't expired, my browser till the end of time, every time it goes to localhost, is going to send this cookie. Because it's seen it before, probably from this class, like a year ago. Okay, that's given up. So that's what my browser sends.
Cookies are supposed to help the server or the client?
Supposed to help?
Help as in, are they designed?
Yeah, it's supposed to help the server.
So,
Yeah, because remember, HTTP is connectionless, and so if you're a browser and you come and talk to me, and then later on you come and talk again, I have no way of identifying you. Now, I could use the IP address, right? But everybody in this room shares the same IP address to any outside website. We all get natted. So I can't just assume that, I see one thing from that IP and another thing from that IP could be two different people. But if I'm a server and I assign you a one cookie and you a different cookie, now I can distinguish you.
and cookies are independent across browsers. So if I open two browsers and
Yes.
go to the same server, I'll get two different cookies.
If you have a Safari and a Chrome, and you go to the same site, and the site sets a cookie on Chrome, Safari won't see it. Chrome stores its cookies in a little SQL database. It's called SQLite. And they're stored on your local machine in some subdirectory. So of course, if you reboot your machine and then go back to the same website, the cookie is still persistent because it was stored on the disk. Cookies are used for all kinds of things. Am I going to talk about it in a second? Yeah. I don't know if we're going to get that far today. Yeah.
What does it mean when people say that there's some cookies that can track you? Like some antivirus software, they'll say remove 12 tracking cookies.
Yeah, I'll explain that in a little bit. But have you ever noticed that if you you Google for, I don't know, a pickup truck or something, and you go to Facebook and down the side there's pickup truck ads? That's tracking cookies.
How come nowadays all these sites are warning me about the cookies that they're using when beforehand they just did it?
Yeah. So I think I've noticed that too. It's only in the last year or so.
Right, yeah.
It's a new law in the EU.
GDPR. There was some new law passed. Is that what it?
Yeah, the European laws now have to go and say, we are putting these cookies on your server.
And you have to consent to it, right? Yeah, so every freaking site out there uses cookies, so they all have some little banner that says you accept the fact they're putting cookies on your box.
It's a new law.
New law. Apparently it's a
European law, but so many companies have to do business all over that just like, screw it, we'll just do it for everybody.
Yeah.
Also like a meme ban or whatever that was.
I don't know if it's related to meme ban. I think just the EU was doing a really big push for personal privacy.
Yeah, huge risk. Yeah.
digression, one of the headers in from the browser is referrer, and it's misspelled. Right? It should have 4 R's and only has 3. This one should be a double R, and it's never going to change. If the browser is sending a referrer, I'm saying, you know, Bryce, I'm coming to see you, and Anya sent me. Like, I was on her page and she sent me to you, so you know where it's coming from. This is sometimes useful. There's an attack on Blade where you need to lie about where you're referred from. And can you lie if you're the browser? Can you lie to the server by changing your headers? Yeah, of course. You own everything that's sent from the browser, including all of the headers. So you can lie about anything. You can lie about cookie values, or what user agent you are, or who sent you to me. All right, it's 1 minute too. So next time Thursday we'll pick up here. This is how data are sent between the client server, and this is from the client to the server. It's post is how you send data, like form data and so forth, and that's in the body. And then when the server responds, it also uses the body to send back information such as HTML and CSS and so forth. And we'll do some demos and examples, and I'll show you how to sniff this stuff and all that. And we'll talk a lot more about cookies too. All right, see you in 2 days.